It's beautiful. It's artistic seeing the images that OCT produces.
We now can see disease, catch disease at an earlier state, and catch disease before it has done irreparable damage.
In my clinic, I see that way. When I see an old lady, I think of my mom. When I see technologies like OCT that can prevent my mom going into blindness, it motivates me a lot.
Being able to appreciate on a daily basis that we do have healthy boys, is something we'll be grateful for forever.
And then Dr. Toth came in and she said, the first thing out of her mouth is she said, "I can fix you." Pretty cool, right? Pretty cool.
These patients, and countless others like them, have had their eyesight threatened by diseases like glaucoma, macular degeneration, and diabetic retinopathy. That they can still see well is thanks in great part to a technology called optical coherence tomography, or OCT. But before it could help those millions, before OCT, there was only an idea. More than 25 years ago, in labs around the world, researchers were looking at the properties of low-powered lasers and discovering that maybe, just maybe, those lasers could be used to detect disease inside the human body. But no one knew quite where it would all lead.
Vision research, like all research, is fundamental discovery. You don't know exactly where you're going. You don't know exactly what you're going to find until you get there.
In the early 1990s, right, it wasn't clear that this technology was going to work. No one envisioned it would go as far as it did. And certainly industry's not going to, most industry won't touch very basic research like that.
In general, industry and philanthropists want you to do something specific. And that's great, and those are important things. But the invention occurs, the discovery occurs, when a scientist or an engineer is able to use their own imagination and creativity to push forward the science and the technology.
With private capital unable to invest in progress at such an early stage, it falls to our governments to ensure that scientific curiosity gets the funding it needs to thrive.
There's just no chance OCT would be where it is today, benefiting people, powering economies, improving quality of life, if it wasn't for government funding.
Without government funding, we would not have been able to do research.
In optical coherence tomography in the early days, we were supported by the Air Force, and the Air Force was very interested in advanced optical and photonics technologies.
And that was actually part of Star Wars. You never thought of Ronald Reagan and Star Wars having anything to do with OCT, but it indirectly had.
That Air Force money also gave Professor Fujimoto's lab the license to explore more broadly, and he was curious to see if they could accomplish their goals with simpler, less expensive types of laser light.
As a side project, he asked me to look into that and produce demonstrations that we could publish.
In Japan, and also in the Vienna lab of Professor Adolf Fercher, researchers were experimenting with these same low-powered lasers. Before long, in these pockets of work around the globe, the researchers realized that they were onto the beginnings of a powerful diagnostic tool. The world, however, wasn't quite ready to embrace this new technology.
Because I remember when I was a master's student, I gave my first talk in 1991 at a conference, and they told us, "What are you guys doing?"
That skepticism meant that industry was not yet ready to take a risk on OCT. Government investment remained critical to its progress, and in the US, that continued funding came largely from the National Eye Institute.
I am quite pleased that my predecessors here at the National Eye Institute saw the potential value of this as far back as 1991 and put money on the table, put risk money on the table to develop that technology.
OCT was developed. Industry stepped in to bring the technology to market, and by the early 2000s, OCT systems were appearing in more and more ophthalmology clinics around the world. OCT had become an unqualified success, and society began enjoying the returns on those early government investments.
If you look at it from an economic point of view, what has that produced? There's been over $2 billion of system sales. So that's system companies building products to supply to the OCT market. If you look at it from a healthcare point of view, 100 million people, that's almost once a second. Somewhere in the world is undergoing an OCT scan And these are making critical decisions on blindness and now cardiovascular care and cancer. So it's just had a tremendous economic impact and a tremendous impact on quality of life.
I can't imagine a better story anywhere where government support has led to such a remarkable private sector windfall for everybody.
But in the end, calling this government funding obscures what's really happening here.
Actually, it's not government that's funding, it's you and me, it's society. Society is built ultimately on progress. To treat people in the future, we need to do the fundamental discovery biology right now, today. That is research that only society can fund in aggregate, and that funding comes through government sources.
It's you and me, all of us, pooling our resources to ensure that our brothers, sisters, mothers and fathers, our children, all of us, will be better off tomorrow than we are today.